Welcome back. This section is a large section, and it's broken down into 3 smaller sections. This first section we'll be talking about charting basics, degrees, minutes, and seconds that are used for latitude and longitude, chart quadrants, and understanding magnetic north. There are 3 types of aeronautical charts that are used by VFR pilots, but only one is of concern to SUAS remote pilots in command: the VFR Sectional Chart, which comes in print or digital format. VFR sectional charts are on a scale of 1 to 500,000 in print form. 1 inch equals 6.86 nautical miles, or approximately 8 statute miles. VFR sectional charts provide a lot of data, including airport data, navigational aids, type of airspace, the kind of topography, and ATC communication frequencies. Let's start off with lines of latitude, which are parallel to the equator. These are called parallels of latitude. They are equidistant from the north and south poles, and measured in degrees north or south of the equator. Parallels of latitude are black lines that are drawn from left to right. They are horizontal, and the equator is 0 degrees going on up to 90 degrees for the North Pole, and the opposite for the South Pole. In the United States, the lines of latitude increase moving north. All right, longitude. This begins with the prime meridian. This is 0 degrees, 0 minutes, 0 seconds. This is a line that runs from the North Pole to the South Pole and passes through England. This is considered the 0 line. Let's start at the prime meridian, which is 0 degrees, and move west to 180 degrees. Or we could move east. In any case, it's the same place on the other side of the planet called the anti-meridian. Lines of longitude are vertical black lines that are drawn from the North Pole to the South Pole. In the United States, the lines of longitude increase from the East Coast to the West Coast. Latitude and longitude are measured in degrees, minutes, and seconds. In this case, 1 degree is 60 minutes, and 1 minute equals 60 seconds. The traditional format, or the original format, is typically degrees and minutes, or degrees, minutes, and seconds. Another way is the decimal format, which is degrees and then decimals. Converting between DMS and decimal is pretty easy. If you have the DMS, simply divide the minutes by 60 to get a decimal. And converting from decimal to DMS is just as easy. Simply multiply the minutes by 60. So here we have latitude and longitude order and format examples. In this we have Flagstaff Airport, which is 35 degrees 8 minutes north latitude, 111 degrees 40 minutes west longitude. DMS will represent this as 35 degrees 8 minutes north, 111 degrees 40 minutes west. To convert to decimal, simply divide the 8 and the 40 by 60 to get the following: 35.13 degrees north, 111.66 degrees west. VFR sectional charts are divided up into quadrants, and quadrants are 30 minutes latitude by 30 minutes longitude. They look like a rectangle with the long side belonging to the longitude vertical lines. And each side of the quadrant has 30 tick marks, 1 for each minute. They are further subdivided by 2 10-minute tick marks, which are large, and 3 5-minute tick marks, which are kind of medium. Here are the 10-minute tick marks. And here are the 5-minute tick marks. Degrees of latitude north of the equator increase moving up. Degrees of longitude west of the prime meridian increase moving left. Again, let's take a look at Flagstaff Airport in Arizona. At 35 degrees 8 minutes 25 seconds north, 111 degrees 40 minutes 9 seconds west. First thing we want to do is find the 35 on the VFR sectional chart, highlighted by the red box. Once you have found the 35, simply follow the tick marks, adding them up to 8 going north. Next up is longitude. Find the 112 and the 111 on the VFR sectional chart. These are highlighted by the red boxes. Using the same method as the latitude, start at 111, follow the tick marks, adding them up until you get to 40. Let's briefly talk about true north and magnetic north. True north are all the longitude lines that meet north of the equator, and true south are all the lines that meet south of the equator. Magnetic north, however, is a response to the Earth's magnetic field, and the term magnetic heading is the direction with respect to magnetic north. We understand true north and we understand magnetic north. The difference between the two is called variation. That's the angle between true north and magnetic north. A couple key points worth noting. The magnetic North Pole is not a fixed point. It moves around, slowly, but it does move around. And some locations on the planet have magnetic disruptions.